Hybrid brake system. The negative current in scan data indicates regenerative braking. But let's take a deeper look at scan data and see what all is going on here. First, let's look at RPM on the top line. Notice the sudden change where it dips down. To make that fast of a change in engine RPM requires that the brakes were applied. So we're studying scan data when brakes were applied to slow the vehicle. Now, as you look down one column at the motor generator 2 current, you can see that as we apply the brakes, it takes some sudden dips and goes down very deep. Goes down to minus 97 amps. 97.42 if you want to be precise. But we're down 97 amps, negative. Now, don't let this bother you. This is not an alternator that says it's discharging. This is a motor that normally draws current. When a motor puts out current in a hybrid, it shows up as a negative in scan data. That means it's putting out current, not drawing current. And then the last thing to look at the bottom is voltage climbs. As you see what happens as we start decelerating, voltage climbs up to that dotted line, which is 18.4 volts per cell. So what we saw from this scan data is a vehicle made a sudden RPM change indicating brakes were applied. The control system changed motor generator 2 into a generator. Battery voltage per block climbed as we charged the battery. Let's see why all this is happening and how much power are we talking about. So the scan data showed us 18.4 volts per block of two batteries. Back here you're looking at it, 18.414. We're 20 blocks in our battery pack. So 20 blocks times 18.4 equals 362.8 volts. Now power is amps times volts. So 362.8 times the 97 amps we were generating says we were generating 35,278 watts of power. Now the reason we do this to show you is in this particular case, the amount of power being generated is really high. The amount of brake force being used by the generator is very high. Let's talk about brake force in the generator. The electric brake control module works with the power inverter, the hybrid control motor, and the traction motors. They all go together, and braking is supplied by the friction material and the negative torque from the friction motors, both at the same time, in proportion to what is being requested. Regenerative braking can supply about 90% of the stopping power at 60 miles an hour, leaving only 10% friction braking. So when you apply the brake at 60 on a normal stop, normal ABS operation takes place on slick roads, panic stops. None of this applies during normal braking. Regenerative braking at 60 miles an hour will be about 90%. We'll prove that to you by going into scan data and looking at it when we go into our in-depth scan data. All of this goes back to scan data. Now, keep in mind that front-wheel drives use standard rear-wheel braking action. There's a balance between the rear and front brakes. The 90% regenerative and 10% friction apply to the front wheels on a front-wheel drive car. The rear wheels get their standard braking action. Now, we're going to break this down. Let's see how all these decisions are made. First of all, we've got to brake hydraulic pressure sensors reporting to the ABS traction control system controller. We've got a brake pedal position sensor, wheel speed sensor, accelerometer, particularly on the hybrid, the escape, and stoplight switches, all indicating brakes are applied, how much brake, how much pressure. Now, this module is going to determine how much of that hydraulic pressure to utilize. Let me say that again. We have hydraulic pressure applied because you applied the brakes. But the ABS, in this case, has not applied that pressure to the friction material. It first talks with a hybrid controller to see how much the hybrid controller wants to do, which in turn runs the power inverter, current sensors for reverse torque, looks at the resolver and says we want to reverse torque of a certain amount of power. Then it looks down at the battery pack. How much power can you handle? What's your state of charge? What's the temperature? When all these things agree, the brake control module is going to decide how much of this hydraulic pressure to utilize. How does it do that? Well, first of all, let's finish this up by saying all of these modules are communicating through the CAN network. It has to be a high-speed CAN for all this to happen so fast. But here's what we got. Here's a diagram. We've highlighted 4 pressure sensors. On the left is 2 pressure sensors, our hydraulic pressure sensors on the front. On the right is hydraulic pressures on the rear. Now there's 2 pressure sensors on the front that looks a little strange. One of them's in the orange circuit. It's possible to apply pressure to the whole braking system in case one of these fails to block it off and still have braking. We won't get into redundancy. The top breaker, the top sensor in this case, is the one that's reporting to us. The electronic brake controller says I have this much pressure. It's then going to look down and decide how much of that pressure to allow to pass the front blocking solenoids. Now, in a normal braking system, blocking solenoids are open. These are closed in hybrid. And the electronic brake controller, easier than calling it analog brakes traction controller, the electronic brake control module, is going to determine how much of that to utilize. Now it can let some of it pass. If it's too much, it can block them off again and use the dump solenoid. Notice the dump solenoid releases this pressure back to the blue return line. It can dump pressure, and between duty cycling these 2 solenoids and using the pump, remember this is an electric pump that's supplying more fluid to keep pressure up. The ABS system, brake control module, whatever you want to call it, can precisely control the amount of friction braking we have on the front wheels. Now, just a reminder, front wheels are controlled, not the rear wheels. Rear wheels have normal ABS action. We're going to maintain the standard thing. Now, the electronic brake controller will produce about 10% of the braking for the front brakes at 60 miles an hour in our example. It's going to use the blocking solenoids and the dump solenoids to maintain this ratio. Now, the electronic is also going to apply rear brakes for normal balance, as we said before. Normal ABS rules will apply in case of a lockup or panic stop. The hybrid control module is going to be responsible for 9% of the braking. That's why you saw us generating 35,000 watts of power. It needed that much power to reduce speed. Now, the ratio is going to decrease as we slow down. At 10 miles an hour, friction braking takes total control, and we have our total friction braking supplied. And we're talking about, just to remind you, we're maintaining the balance again.